Thank you very much. Welcome everybody. Thank you for coming. My name is Latin. I'm a solution architect for AWS. I work with our partner team. I actually come from a pretty long Microsoft background. I used to be a Microsoft Most Valuable Professional for many years. I worked with several different Ranger teams, as well as I went through the Microsoft Certified Master Certification and training at a time. I continued working on Microsoft ever since I joined AWS. It's been a passion of mine, and I'm privileged here to be talking to you about how we run Microsoft workloads on AWS. So, what is our challenge with running workloads on AWS? Can Amazon's Web Services simplify the infrastructure environment for us that we already know very well and we run, right? Things like Active Directory or any of our corporate applications, Office 365, Exchange, SharePoint, Dynamics, System Center. What about SQL? What about any .NET applications that accompany that? How do we deploy all of this, right? And then what about all of our workloads that we already have that are either running on a different cloud or they're running on a data center? You know, can we simplify migration specifically of Microsoft workloads into AWS? Can AWS make management of my Windows workloads more simple? So these are all the challenges that we have faced over the years, and I'm here to kind of give you an overview and tell you and show you, hopefully by the end of this webinar, that Microsoft is a first-class citizen on AWS, on our platform. We're very proud of it. And hopefully you will find it just as easy and just as awesome as we do. Simplifying infrastructure environment. We've had several different innovations over the years, starting from 2008 onwards. We've added 41 instance types. We have 10 instance families. We have supported Windows Server 2003 way past any support from a Microsoft side. If you happen to run it with RMEs and our instances on AWS, we have had 300 different Windows ISVs that are listed in our marketplace, and there's more and more coming every day. So we have both the ISV as well as the ISO consulting partners that are helping our customers worldwide. In fact, we have gone all the way up to supporting things like Windows containers, providing services that we built specifically for Windows, like Systems Manager and so on, and running .NET code on Lambda on our serverless services that we have available. So let's start from the beginning. Where do we start from? How do we connect to AWS, right? How does this actually fit the type of solutions and type of networks from your data center or another cloud to AWS and all that, specifically for Microsoft workloads? And they are specific in a way. What's really specific is that Microsoft workloads have a lot of shared services. You're going to have definitely things like Active Directory and all that a lot of workloads in Microsoft ecosystem use. You'll also have things like farms that you'll have separate SharePoint farms that are perhaps serving different users. You have SQL farms that may be serving multiple different applications that can be in different VPCs or networks, and things like System Manager and so on. So one of the things is we have a shared service VPC where we allow VPC peering to multiple VPCs. So your central services will be in the shared services VPC. And for those of you that are perhaps very new to AWS, VPC is really our network boundary. It's designated by the CIDR block range, and it consists of multiple subnets. Those subnets may or may not be exposed to the internet based on the internet gateway that is attached to them. For the most part, obviously, the workloads will be running in private subnets. And then we have transit VPC, and transit VPCs basically provide it attaches also to the same way to other VPCs. However, they provide transitive properties to all the VPCs. So in a first scenario, the other VPCs can only see the central VPC and they can't see past it. So A can't see B, and B can't see C. However, in a transit VPC, you would have two routers, for example, Cisco CSRs that are kind of set up in a available way in a transit VPC, and they kind of attach themselves to and provide traffic to all the other VPCs. We actually have a solution. You can right now, if you Google transit VPC AWS, you will see a solution that automatically attaches new VPCs as they're being added and provides you with a specific infrastructure for you to use. One of the things about that is that it also allows you to control the traffic that goes in and out of the VPCs themselves centrally, and you can kind of inspect that traffic as it's coming through and the whole thing. It is more kind of similar to traditional data centers than anything else. So what about first things first? Active Directory. That's the first thing that we need, right? The simplest and the best way it has been for years. No matter what cloud provider platform I've worked with, this has been consistent. But extending Active Directory it has been straightforward, whether it was in multi-domain or whether it was in cloud setups. You would establish something like a VPN or direct connect in our case, which is a direct connection into our data centers, and which can provide you with a 10 gig pipe or so. And then once that's established, you would just put two domain controllers for availability and resilience, and you would just effectively extend the corporate domain into AWS this way. That is just as simple as that, fairly straightforward. However, you may decide that you do not want to extend into AWS for various reasons. It could be the fact that Active Directory team does not want to take responsibility or even worry about anything that happens in the cloud, or that they want to manage it or anything like that. You can actually set up federation. And what's really great about this is that you can either choose to set up the DCs yourself in your own separate domain, or you can choose to use our managed directory service, which is AWS Directory Services, Microsoft AD, which actually provides you with both enterprise and standard level, as well as different versions of Microsoft AD that you may use. That is fully hosted by us and managed by us, an entire thing. You can then federate between your on-premise directory to AWS and to the directory setup over there. And then you can also consider, with a connection through VPN or direct connect, once again, to establish a one-way or two-way trust between your on-premise Active Directory and the one you've set up in AWS. Like I said, it's a click of a button to do it, to provision our managed service and have Microsoft Active Directory up and running in AWS, or if you want to set it up on your own EC2 servers, which are our virtual servers, we have CloudFormation scripts, Quick Start specifically, that will quite simply set this up for you. You can just define all the parameters for how you want Active Directory to be set up. What about, you ask yourself, what about our Office 365? We want to be able to authenticate over there. In fact, we have several hybrid scenarios that we want to run, specific to our business, let's say, and I'm just, talking hypothetically here, where we want to include or integrate with any of the services provided by Office 365. Or anything, in fact, any services to which Microsoft Active or other Azure Active Directory is being used to authenticate to. So you can effectively set up, by installing administrative tools, setting up ADFS, and installing Azure AD Connect. You can actually integrate with Azure Active Directory and federate over via ADFS to Azure Active Directory, and in that way federate over to any of the Office 365 applications. And then you can sign in to Office 365 by using your Microsoft Active Directory identities that would then be federated and synced to anything that may be using it on AWS side of things. What about SQL Server? Not only do we have our managed Active Directory, we also have managed SQL Server on AWS, which is part of our RDS service, or Relational Database Service. And that means that we will worry about scaling, high availability, database backups, DBMS patching, DBMS install and maintenance, OS patching, OS install and maintenance, power HVAC, anything regarding the actual infrastructure side of things. So we actually literally worry about everything. We let you decide how you want and which size, and whether you want enterprise or standard edition. You can bring your license, through license mobility. With Microsoft, you can choose to use your own, up to you. And that actually counts also for Windows servers. We can either rent our licenses through us, or you can bring your own license if necessary. And that's a pretty massive advantage for all of our customers, especially those that do not want to over allocate licenses, in their true ups or for enterprise agreements. They have an option effectively to use temporarily licenses that they may need without worrying that they are exceeding the allocated licenses that they have as part of their EA. So things for like development, QA, testing, proofs of concept, and all this sort of stuff. They can rent licenses through us, through our AMIs, and through our EC2 instances, and using our EC2 instances, and as such, they can save massive amounts of money. So we are really here being cost effective. You can also choose to run SQL on Amazon EC2. We actually have quick starts and ready-made CloudFormations, and I'll explain more what a CloudFormation is later on, that actually build out the entire AlwaysOn availability group for you. The only thing here is that you will be worrying about scaling high availability database backups, patching, and OS patching, and we will obviously worry about everything from hypervisor onwards. This is the CloudFormation and the setup that you can right now. If you go and click, like I said, in Google, if you go to AWS Quick Starts and you find it's a SQL Server, you'll find also AD and SharePoint and Exchange and a whole bunch of other quick starts. You can just click deploy, and it will. And as long as you have an AWS account, it will actually go ahead and deploy it for you. It will deploy a file share witness. It will deploy 2 SQL replicas in AlwaysOn availability group in a full sync mode. And with Active Directory set up, and and the full basically AlwaysOn AG SQL setup to work with Active Directory, and then it's up to you then to restore any of your databases, create availability groups, and then test it out. We use it for a lot of proofs of concept. You can also go ahead and extend this or extend your current existing AlwaysOn availability groups onto AWS. And I'll talk about that in context also migrations themselves. But you can use AWS as basically a disaster recovery site for you in case anything fails in your data center. You can then automatically fail over to AWS without any impact to your users or to your business. And vice versa, you can actually you can have your primary SQL setup and your applications and all that running in AWS, and then you can fail them over to someplace else or to another region, and so on. You can also use failover cluster instances. The difference is this is with failover cluster instances, there's only basically node replicas, and the actual storage is shared. So you would need to create some sort of a storage replication between it, because that will prevent you, or that will help you if any of your nodes fail. But if something takes out the storage, the actual redundancy provided with failover cluster instances won't do much. And this is where our partners like SIOS and so on, with DataKeeper and so come into place, where they provide you with these replication and resilience scenarios if you insist on running failover cluster instance. Personally, big fan of always-on availability groups myself. So this slide, I really love this slide because it actually puts together a lot of services, including the ones that I talked about earlier, together into a whole picture to give you a more holistic view of how Microsoft workloads run in AWS. So as you can see, and this is more of a, this is a single VPC setup, although I talked about a multiple VPC setup, which you may need for different departments and so on. This is a very good representation of a single VPC setup for Microsoft workloads. What you can see here is that web servers, whether we're working with enterprise applications or with .NET applications, set in auto-scaling groups, and so are the app servers. And auto-scaling groups, they can serve for for both resilience, making sure that that they monitor and identify any of the sync instances and then replace them with a healthy one if necessary, or they can scale up and down and add more servers or reduce more servers based on the traffic. So if you have increased traffic, they will add more servers, to ensure that your business is running properly and that your application is performant, or they can then subtract servers if there's no traffic, making sure that it actually saves you money and you don't run over provisioned for any case. These are industry strength services. These are the type of things that that our customers like Twitters and Pinterests and Netflixes are running. So you can be sure that this is going to work. Then other things that we have on a data layer, things like SQL Server. Like I talked about, it can either be deployed on EC2 on our instances, or you can use our managed SQL Server instances that are being set up to replicate between two availability zones. And same goes for the for Active Directory and domain controllers. You can use our own AWS managed Active Directory, Microsoft Active Directory, or you can use a deployed Active Directory that you yourself deployed on our virtual servers. We also have things like net gateways, which actually provide you with netting, which allow your internal servers to actually pull updates without them being exposed outside. Things like load balancers, we have network load balancers, application load balancers, and classic load balancers as a service that you may use. The external load balancer will ensure that it provides traffic to internet users without you having to actually put web servers into a DMZ or public subnet at all. So you can terminate ads and put certificates on to Elastic Load Balancer over here, and you can also have an internal one to serve internal users for the same application or a different one. We also have web application firewalls. We have our own DNS service called Route 53. We actually are also a trusted certificate authority. We have our own CDN network through CloudFront. It works really well, and we have services like AWS Shield that provide DDoS protection. But let's look at this. If you see, we have two availability zones, and we have subnets that are split between those two. So we have one private subnet in availability zone 1 and another one in availability zone 2. And the reason is that availability zones and this type of setup itself is pretty much equivalent to the full-blown DR setup, right? Why? Because you know, although it looks, you know, kind of is part of the same LAN, and it is part of the same network with the same speed in single-digit milliseconds between each of the availability zones. However, it's important to know that each availability zone is a cluster of data centers that is in a different floodplain, fault plane. So not a single natural disaster or unnatural disaster can affect more than one availability zone at a time. They're more than 50 miles apart, of course, and all that sort of stuff. But you know, it's really important to note that, you know, how much separate they are. They use different providers from an electricity perspective and all that. There's just a lot of things to which contribute. Like I said, these are clusters, two separate clusters of data centers, and some of our regions have obviously a lot more than just 2 availability zones. I think you can go up to 5 and so on. Here you can see you connecting from your data center via VPN and direct connect, like I mentioned earlier. But also you can take advantage of a lot of other services. We have really good DevOps services that I'm not going to dive into because that's going to be a separate presentation. But things like AWS Code Deploy, AWS Code Pipeline, Code Build, and Code Commit all work really well with Visual Studio, and they work really well for .NET application. What are we talking about? .NET applications that are running on .NET Core, or they're running on legacy .NET, or they are running in containerized microservices. They're running kind of in a more traditional way on web servers. Our DevOps services support that. They integrate with VSTS and TFS as well. We have monitoring and auditing and logging via CloudTrail, CloudWatch. We have a S3 service and our Vault, as well as archiving service Glacier, working in conjunction with S3. And S3 can actually have VPC endpoints directly into your VPC network, making sure that you take advantage of it. You can offload your media and your files on it, and you let your applications use it in a performant way. And S3 is something that has 11 nines durability, which is pretty amazing. A lot of configuration and system management services, out of which I will actually show you and demo you one of them. We also have IAM, Identity and Access Management, Certificate Manager, and KMS, as well as Cloud HSM for encryption and compliance. So simplified infrastructure deployment. I mentioned to you a couple of times CloudFormation. CloudFormation is really our infrastructure as a code. It's a template that is either JSON or YAML based. Everything, both JSON and YAML have their pros and cons of being used. I guess YAML is a smaller format, but JSON it makes more sense to me when I use it, at least. You can then build out stacks and define exactly what part of what your design of your infrastructure is, and how do you want to design and how you want to create it, and you can declare that as a code. Now this is tremendous because first of all, it's smart enough to realize what it needs to create first in order to what it needs to create second, and so on and so forth. Of course, for specific applications, you can establish that that kind of dependency, but it will completely create your entire infrastructure from scratch. All of your applications, pull them. It will also bootstrap all of your servers, ensure that they've been properly updated and everything for them is properly installed, and it handles any of the restarts on the things that you need to worry about, especially for Microsoft workloads. How does it look like? You can either create a template yourself in Visual Studio or in a text editor of your choice. You can save it locally on an S3 bucket. You run it through our service. You can run it through CLI command line, or you can run it through our console, which is pretty cool. And then our service just goes and builds the entire infrastructure for you. Quick Starts. I mentioned to you Quick Starts. Put in Google right now AWS Quick Starts, and you will see a whole bunch of Quick Starts in there. What the Quick Starts are is that it's already created CloudFormations. These CloudFormations, I highly recommend them because a lot of them have been used not just for POCs and so on, but in fact they were used for basis for actual production deployment of these workloads for many of our customers. And trust me when I say that, I work with them directly on this, so I highly recommend them. Next thing, how are we going to simplify migration, right? So now we have our entire infrastructure. Now we have how the deployment of infrastructure is going to happen. We have all of this. How are we going to simplify migration? Well, we have actual migration tools from us, both us and our partners, and we support our partners just as well as our services. So although we have our own, and this is how we separate. We have discovery and planning services, 7 database migrations. We have data transfer services and application monitoring and profiling. And you will see a list of partners here like Cloudamize, Risk Networks, Cloud Health, TSO Logic, but we also have our own AWS application discovery service. For server and database migrations, we have Adadata, Cloud Endure, Cloud Velox, Velostrata, but we also have our own AWS server migration service and more importantly, AWS database migration service, which has been actually extremely popular, specifically because it allows not just database migration, but it allows real-time migration, eliminating the need for you to kind of transfer over backups or rather deltas of backups and things like that, and having to worry about downtime. So it will work with a zero downtime. And data transfer, things like S3 transfer at Unity from partner side of things, but also S3 transfer acceleration, AWS storage and file gateway, and then we also have snowballs and snowmobiles. And for those of you that actually went to our reInvent and have seen this, Snowball is really a box that we send you, and this box is super protected and super secure. We've been dropping it for like from massive heights down and making sure that it still works and demonstrating how difficult it is to break into them. Obviously everything in there is completely encrypted, and you're the one who holds the key, so they even if someone wants to get in, they can't get anything out of it. And we use it for transferring of petabytes of data, and very commonly. So it's not just it could be images of your servers that you've been running on premise, on your VMware or something like that. It could be data backups of your SQL servers. It can be a hell of a lot of things, and that's to make it even better. We actually have an entire truck that comes in, and you can store petabytes and petabytes of data into this truck, just the same way, works in the same way, and all that. It's very streamlined process, about people coming and picking it up. And fairly quickly all this data will be available to you in AWS. We have literally migrated entire data centers by means of this. AWS Direct Connect, I talked about it before. This actually provides you with a direct optical cable connection into our data centers. It provides you with dedicated bandwidth, 1 gig or 10 gig. And depending on your providers, it can also be kind of different parts of that, and you can use it temporarily to migrate massive amounts of data into AWS, right? And switch it off when you don't need to use it. Then application monitoring and things. We have our own CloudWatch in AWS config. However, there's a number of our partners like AppDynamics, Dynatrace, and New Relic that also provide this. Some of them are good for certain workloads, some of them are good for .NET, some of them are good for Java, some of them are good for all of this. And for the most part, these 3 partners have been particularly excellent for application monitoring on our side. How does the migration actually work, and how does it look like? So you would have your on-premises data set. So this could be a SharePoint that is running, or it can be really any other application in there. You would actually set up an account structure. You would design your VPC. which would include, the CIDR ranges allocated to both the VPC and the subnets. This is something your network team would provide. And then you would set up the security. You would set up all the monitoring together with the security. So you would have everything from security groups that are effectively proxy rules on how the servers are going to kind of communicate between each other and outside, obviously, if necessary. Web application firewall, if necessary, any of the load balancers, anything that you may need, including things like system manager, inspector, config, and so on. Then we're going to extend Active Directory. Like I said, that's the first thing. Whether we do pure extending, or whether we actually do one-way or two-way trust, or whether we do federation over. And then we're going to basically extend. So now we have an extended domain. Now we can extend the actual AlwaysOn availability group and set up, or we can set up another level of replication between SQL Server on EC2 or SQL Server running on our RDS. And we can use, AWS database migration services, or we can use any other third party, or we can use Microsoft's own, obviously, services like AlwaysOn. Zero-time downtime migration that is achieved through that will allow us, once we actually set up both web servers and application servers over VPN Direct Connect, then we can just cut over by either using your DNS or using Amazon Route 53 onto AWS without users even knowing what happened. So you can actually there's a lot of ways that you can do even connection draining, specifically for your on-premise setup in your on-premise servers. You can do weighted as well, weighted DNS approach, where certain percentage of connections only going to go on-premise, and then increase the number of connections over to the AWS until you fully drain and fully switch over to AWS. Once again, with zero downtime. You can test your cutover mechanisms. You can do all of that before you do it, and you should really maintain your rollback after cutoff if possible. There's also AWS Server Migration Services. What's really great about this, right now it supports VMware, but soon we will have support for other virtual machines as well. It's an agentless VM migration. It will actually capture incremental change made into on-premise VMs and automatically transfer them over to AWS. It will migrate groups of VMs simultaneously and provide orchestration for all of your workloads. And you can either use it by API or through the CLI or command line access, up to you, however you want to. You will also go through your discover and migrate and track. As you go through, we have our Migration Hub that provides all of these services, and then you will be tracking status specifically through Migration Hub that shows you things like this, which workloads have not started, which ones are in progress, which ones have been completed. You can actually track down and see the performance of migration and identify any particular issues that there may be, and address those in time. And you can see that from the actual dashboard, and you can see it kind of from an overall performance of the entire massive migration as it's going on. So it gives you quite a bit of power, quite a bit of insight. What about management? Well, this is something I'm going to also show you now briefly. The Assistance Manager capabilities. You can deploy, configure, and administer Windows servers and Windows applications. You can have shared capabilities like a maintenance window and use parameters tool. And you can track and update both your inventory, patches for all your servers, and provide automation for most common. And I'll show you kind of that in a demo as well. So remember this, things I'm going to show you, everything really revolves around documents. And documents are kind of scripts that define. We've created a whole bunch of them, and you can create your own if you want to. But we created a whole bunch of them specifically for Windows. So for services like run command, which is great. State manager, patch manager, automations, and so inventory and maintenance window, as well as parameter store, which can be used both by your servers and your applications. And it will allow you basically direct management, of your servers without you having to even be in the network itself. Things like, quite simply, things like run commands and stuff that allow you to actually execute any type of PowerShell command or any type of configurational change into any of your servers or applications, literally via the server. So you could be using CLI, which is basically our command line way of talking to AWS services in a very secure way, or you can do it even via the console itself. You can administer all the servers. You can, like I said, run commands will run your PowerShell scripts. It will run your configurations. It will run any changes that you may need, and so on and so forth. So CloudWatch and Amazon CloudWatch logs. Basically, you can see all of the metrics of all of your servers running, from CPU to disk usage, network usage, and so on, to as well as all the resources like your volumes that are being used, Elastic Load Balancer, and anything else that comes with it. And it will also allow you to monitor logs and configure alerts specifically on what you want to be alerted for and all that sort of stuff. So, and if you pipe SQL logs into CloudWatch, you can say, hey, send me anything, kind of anything greater or less than of like Sev 15, 16, or 17 errors, and so on and so forth. So the way it would look like is that you can actually configure the logs from SharePoint or from SQL or from your Active Directory domain controller to be sent out to CloudWatch, and those can be pushed via or by means of Kinesis. Kinesis is a great service on our side, which actually allows real-time data processing, log processing. It's even used in media and so on to actually shoot out in real time massive amounts of data. Or we can use CloudWatch alarms, which is fairly easy to set up. So you can set it on a specific event. Each of these can be, or each of the logs and the specific parts of the log can be configured as an event, and that event can start a workflow. They can send out an email or send out an SMS, in fact, and inform you, via SMS on what happened. You can also, from a log perspective, you can send them into Lambda. Lambda can then talk to different services. It can even talk to like Slacks and Teams or anything like that. You can store it onto S3 storage for review and analytics, or you can put it into Amazon Redshift, which is our data warehouse database, specifically designed to be extremely cheap but extremely performant, commonly used really with all of our analytics tools and so on. So what does it look like? What I just explained. You can send out logs either, once again, from EC2. They could be network logs like VPC flow logs. It can come out of the CloudTrail, which is effectively, CloudTrail is our service that keeps track of all the API calls, and in that way provides an audit of what happened, because anything that goes out to our services is an API call. Doesn't matter where it comes from, it's always an API call, right? It could be from CLI, it could be from the actual console, or anywhere else. You can use, for those of you familiar with Elk Stacks, you can use Elasticsearch service that then displays everything on Kibana. You can send it to our QuickSight, which is our BI on demand, our business intelligence on demand tool, which uses its Spice engine for real-time processing of data, and you can build your own dashboards and things like that, and show quick analytics of massive amounts of data. Or you can, like I said, send it out to Teams or Slack and inform specific teams of something that happened. Very common. People will change like proxy rules, which is security group rules or something like that, SecOps teams want to be immediately notified of these things and provided with relevant information on their Slack channels. But before I go to thank you, I want to go ahead and show you what System Manager is. This service really has been done, or rather we've created it with Windows workloads in mind primarily. That's how much we love it. You can identify, so this is kind of what our EC2 looks like. You'll see that I have a whole bunch of servers here that are deployed, all kinds of different servers, all kinds of craziness. And one very important thing is that we use tags to identify any of our resources. And all of our services use and search for tags in this particular case. So first thing we want to do is that we want to find resources, right? So we're going to say it's going to be EC2 instances. I can say that it's this is going to be the key, and then this is going to be the value for the key, and that's just the key name and the key value. And I can say, hey, I want to view this query, and you can see all of the instances, and you can say, hey, save this as a query group, and I can give this group name. I can say webinar group, a description, and I can give it tags if I want to. I'm not going to do that now, but it's a good thing to good practice to give them tags. And now I have a saved group. I can look at all my built-in insights that I have in there. I can select the group that I have here, and then I can look at, right now it hasn't been tracking any, but it would check the compliance rules, it will check non-compliant rules, or any of the things, or the config history that has been changed. So config provides effectively a tracking of any changes to the infrastructure. If you're wondering if they changed your instances, or changed access to them, or changed security groups, or changed any aspect of the infrastructure, this will track it for you. CloudTrail, same thing. It's going to show you what the last command that was run, and you can kind of go through for this group. You can see some of them. The last one was, I guess, create tags and so on. But you can go back into history and see what else happened. You can actually look at your CloudWatch operational notifications, and more importantly, you can also check out your trusted advisor. And we'll go through that into if you actually go and check out more details. You can see here that it actually runs and advises you specifically on, like, if you're wasting money on some things. You can see I have warning signs. Some things I'm doing pretty well. Here it has a comment on my reserved instances optimization. The instances have been running for a long time. They're suggesting, hey, perhaps you should run those as reserved instances. That will actually save you quite a bit of money. Or I can go into things like security and all that and see things that I've done wrong here, like, with a massive hell no sign to say the access, my access keys rotation. Well, they haven't been rotated. They should be rotated. It will give you what the recommended actions are, what those keys are. You'll see the reasons why those things are happening. And same goes for security groups. Is you have a whole bunch of specific ports that are unrestricted for these instances. It will also say the security groups also have unrestricted access, and these are the things that I should be fixing. So if I go down, if I look at the dashboards, you can see the different types of dashboards that you can kind of here create. Let's say we give it a name, webinar dash, and I'm really going to create one of the widgets. So I'll say stacked area. I'll go ahead and configure it, and I will here choose, I don't know, EC2 metrics. I'll say across all instances, and I'll select CPU utilization, disk read bytes, disk read ops, write bytes, write ops. I will create a widget, And then I can kind of stack up and create as many of these widgets as I want to, and create an actual dashboard of monitoring all of my Windows resources. So yeah, I'll say I won't save this thing. I will go into inventory. This is kind of where you keep your top 5 OS versions, server roles, and so on. Right now, I just created this group, so once it's been running, you would have a full inventory in place. And then you can do things like you can create a patch baseline. And this is the patch manager. I think this is going to be the same thing. You can, and let's create one. So test, call it the webinar patch baseline. Again, I'll give it a description. I'll say Windows that I want to have patched. And I can here select any of the products that are available over here, or I can say patch them all. I can also say whether I want critical update, security, service specs, and so on. I can say what severity I want, and I want auto approval on certain days. So if there's no, if explicit approval hasn't happened, then auto approve them, and they haven't been taken out, auto approve them directly. And then you can also have a compliance level. Here, this is very important. You can say which are approved patches, and those you will specify by means of KB articles. And you can see I'm on Microsoft website, and I'm getting the actual KBs of the patches that are in there. And then you will just add them here one by one. These are the approved patches, so I want these to be applied to my servers. You can also specify what level. This is optional, and you can say which ones have been rejected. So if you've already tested it in your separate environment in a cloud, as you know, you can temporarily set up an environment, test a whole bunch of things. With CloudFormation, you can set up the entire infrastructures and test them temporarily before tearing it all down. You can check, hey, this patch has actually broken my application. I know not to put it in, so I'm going to make sure to put it under rejected patches. And here's my patch that I created. However, they already created patch baselines that we created out of the box. There's a Windows one here, and this one is specifically the one that can be with approval rules and any patch exceptions that can be then applied and used for all of your Windows servers. In order to do that, a lot of people like to have maintenance windows. In Windows world, we have that. So we'll say maint webinar, and I'll say once again description optional, and then I can say, hey, I can use a cron job to say every 1 day, every 30 minutes, every so many days, and at which specific hour. I can say the duration of the maintenance window, which can be 5 hours. So let's say if I know it takes 5 hours to apply patches or something like that, or to download patches because there's so many, God knows, there's gigabytes and gigabytes of whether it's SharePoint or anything else. Sometimes it's for the server itself. And then you can say, hey, type number of hours before the end of maintenance window that the system should stop scheduling new tasks. So you say, hey, stop scheduling new tasks 2 hours before the window closes, right? And we can create this guy to have it up and running. Automation is something I really love, something that I use quite often. In fact, I even work with our product teams on some of them, specifically the one that does update of the Windows AMI. You can see here that this, so let me show you once we once we go to the execution, and then so here you can see various different executions that work both for Windows and Linux. We'll go and look at pretty much all of them. Update Windows AMI. Here we can actually, and this is the one that I worked on with our product group specifically. Well, they built the automation. I built things to actually go ahead and update launch configuration, auto-scaling groups of existing applications, as well as a janitor function to clean up old AMIs and so on. Here you can specify the AMI. For those of you that don't know what an AMI is, that stands for Amazon Machine Image, and that's effectively a snapshot of an image of a virtual server, and you can then run updates on it, or you can do you can actually get it to download any code for more like bloated legacy applications, so that you know, when they start up, let's say in an auto-scaling group or stuff, the startup time is not long. It's as short as possible, and that has been a massive requirement for a lot of Windows workloads. A lot of Windows workloads, when they're starting up, specifically, they have long startup time. So having preloaded patches, having preloaded updates for your applications is very important. And the key here is like it goes and shuts down with sysprep, so it's ready to start up, you know, with any relevant bootstrapping that it may need. You can specify the type of instance that you want to use. So it will temporarily use this instance to actually download and create a new image. Subnet ID, what KBs you want to include and excluded, categories, severity levels, and then, you know, what's the pre-update, post-update script that you want to run, and so on and so forth. This is all that will run for you for Windows. This is gold for a lot of Windows and for a lot of Microsoft administrators specifically. You can run command as well, and it will run a command. Here, the most common one that I use is run PowerShell script, and then you can specify for which servers. You can write a PowerShell script here, and then you can have it executed into multiple servers at the same time, and you can get a response from multiple servers at the same time. So you can effectively run you know, any specific administrative task that you need at many servers at the same time without you having to actually use remote desktop services to remote into them, get into them, run, you know, individually in each and every one of them. No, you can run in all of them at the same time, and you can get output straight away. You can define rate control, output options. You can store it onto S3. You can store the actual results onto S3 bucket if you don't want to just view it all. You can actually use a simple notification service to send it either to emails or maybe not SMSs, but other things, or other services. The SNS will work with various different types of service endpoints and send that information to it. And then if you want a CLI or you know, command to actually configure this thing and not do it via the console like I'm doing, actually based on your parameters that you selected, it goes ahead and creates a CLI command that you would then use you know, as in command prompt. So patch manager did show you maintenance windows. State manager. State manager is very important. It creates association. So what it does, you can say, hey, apply patch baseline. It could be a patch baseline specifically for so let's go. We'll say for platform Windows, and you'll see all the Windows ones that are command documents that we have. So it's basically a script, and what this does is that this periodically, based on you know, either scan or install operation snapshot ID, depending on the type you know, of the document that you're running, it can then periodically you know, enforce this configuration, check if any configuration has been changed, change it back if necessary, and that way maintain actual compliance within your infrastructure. And you can also write the output to S3 if necessary, and so on and so forth. Where does all this come from? Well, it comes from documents, and this is kind of what these documents look like. As you can see, I have a lot of them. Once again, if I say platform types in Windows, you'll see all the Windows ones that we have. Create snapshot, install application, install PowerShell module, install Windows updates, delete snapshot, and all that. Although we have a patch manager to install Windows updates, you can actually run you know, yourself these commands in there. if I go ahead and open it up, you can see the content over here. It's all using a schema-based language, very easy to understand, very easy to see what it takes in and what it executes. And you can see exact things that it executes here, how and why and all that, the actual PowerShell scripts that are included, and so on. You can see the parameters that it takes, which one's optional, which one's not. You can also tag it, and you can view previous and other versions. Activations, very important. You can actually install a System Manager client onto on-premise servers or servers that are running on a different cloud, and you can have them managed in the same way by the System Manager here. So activations is activating those servers that are outside of AWS that you want to manage through System Manager. Very important thing to note is that System Manager is completely free, right? And last but not least, this is what a lot of applications use it, serverless applications, .NET applications, and so on. You can store secure strings here and parameters that can be used by many applications. You can choose an encryption key that you already created, that you already use, and you can put in a value. Now, this value could be a connection string to the database. It could be anything else, but some things that you wouldn't want anybody to see. You can create that parameter, and you can then specify any other applications that may use it, or any other serverless AWS applications that may use it. Right. Once again, this is all free, folks. All free. There's no charge for using System Manager, except obviously for the running of the servers and all this sort of stuff. So, if a patch manager is using servers, or rather if AMI update is running, it needs to start a service, create an AMI image, and all this sort of stuff. It's just the running of the servers that it's gonna be charged. The actual running of System Manager is completely free. Thank you so much for coming. If you have any more questions, please don't hesitate to contact me. This is also my Twitter handle. If you want to follow me on Twitter, I do output quite a bit of updates, a lot of them that are specifically for Windows. So feel free to do so. Feel free to reach out. We love taking questions. We love nerding out. So thank you very much, and enjoy the rest of your day.